Hi, this is FIFA once again, and we're continuing the series on the classic wrapper. We talked about the use case and the enforced classic wrappers, which were aiming at asset issuers. Now we're going to talk about the optional version, a way that's less restrictive and offers a different path that is optional for users to go through the custom behaviors whenever someone wants to extend the classic assets capability. So let's get into it. Alright, so let's start with explaining what this demo, this use case covers. We are going to explain the use case, then we are going through an interactive demo once again. This is hosted on my website and I'll show the links afterwards and put them in the description. And then we're going to dive into the code to see how it was implemented. So let's dive into it. To start off, just recapping, when we're talking about classic wrappers, we're talking about having the classic asset, having the SAC contract, that is the default implementation provided by the network, then adding two other contracts, one as the wrapper, which is going to be the new entry point for the asset, and an additional contract with the special rules or special behavior we are adding. In this case, as we're going with the optional approach, this is not a restrictive interface. This is an optional interface. So anyone can choose between using the classic asset directly, the SAC directly, or using the interface and going through the custom behavior. And in this case, the custom behavior is a campaign use case. Let's imagine a marketing campaign that a wallet or multiple wallets or the asset issuer or anyone that wants to promote usage of this asset is implementing. And let's say that this campaign is going to award points whenever someone interacts with the contract, and then once they accumulated enough points, they're going to get some cashback, some tokens as a reward for using the token. So let's dive into the details of how this was implemented. So let's go through the elements that we have in here. First, we have the classic asset, which is a default implementation, no custom control flags, so it can be accessed by default by anyone. We have the SAC, again, no control flags, no customization. Then we deploy the optional wrapper. The optional wrapper is another entry point to access and interact with the token, but this time it's not restricting access to anyone. Anyone can use it as long as they want to abide by the additional behavior. And if someone wants, let's say, the builder of this use case, they could say that the wrapper is only accessible by their users or a specific set of premium customers that will have special cashback or points or rewards attached to their token. So this is how you could leverage this approach for a different use case than the enforced ones. So here it's going to be accessible by anyone, and it will trigger the campaign contract to review the transfer transactions. The campaign contract cannot be accessed directly in the same way as the other use cases, so we don't want people messing with the rules or generating fake transactions. We want to verify the transactions and execute the campaign on top of those. So we don't want to restrict the transactions, we don't want to make them fail. We just want to ensure that whoever is participating in the campaign is going to get some additional points and cashback. And in the end, it's going to hold the funds. We are going to fund it with some tokens, and whenever someone meets the threshold, they're going to get the prize. So let's have a look at how this looks. The way it's going to look is, let's say our friendly dog here is going to make a transfer. He's going to use the optional wrapper because he wants to participate in the campaign. Who wouldn't, right? So he's going to trigger the transfer, and the transfer will be redirected to the asset controller. In this case, it is the campaign controller. So the campaign controller will verify its own rules. Different from the enforced approach we did with the probation, here we have other parameters. First, we have a campaign period, which is a global parameter for the whole campaign. Let's say the campaign is valid for 3 months. So during these 3 months, if someone uses the wrapper and goes through the campaign, they're going to be getting points and be able to get the prize. Once this period is reached, the campaign will just pass through and won't award any points or give any prizes. So during this interval, what it's going to do is it's going to have a prize amount, So how much anyone is going to get whenever they reach the threshold. They're going to have the target points, which is a parameter to define how many points they need to accumulate to get the prize. So I can say, hey, 1,000 points is enough, maybe 1,000,000 points, maybe just 10 points. It all depends on the multipliers. So that's why we have the inflow and the outflow multiplier. Whenever someone makes a transfer, let's say the dog is sending the chicken 10 tokens. We can have an inflow and outflow multiplier that are different. So let's say that he gets a 1-to-1 point for tokens sent. So let's say he gets 10 points for the 10 tokens he sent. And let's say that inflow multiplier is half of it. It's half of the amount. It's 0.5 to 1. So the chicken will get just 5 points by receiving 10 tokens. So this way they're getting points depending on how they're interacting with the asset. So they're going to accumulate points, and these points will fill in their small bar. And once they get to the target point, let's say it's 100 points, once they get to 100 points, the contract will automatically distribute the price in the same transaction. So as I do the last transfer that make me reach the threshold, I'm going to get the price. And let's say the price is 100 tokens. So let's say that in the end, I only need to run 10 more tokens. I am at 90 points, and then I run these 10 tokens, get the 10 points. And as a result of this transaction, I'll also get my 100 tokens prize. And once someone reaches the prize and gets the prize, we have a wait interval. And this is a way of playing with how many times you will allow someone to get the prize through the campaign. So you don't want people spamming transactions and just accumulating a lot of points between their friends just to get the prize. So you set an interval that, let's say the chicken has reached the 100 points and got the prize, then the waiting interval is going to be applied. And let's say now the chicken has to wait until April 7th in order to start accumulating points again and then get the prize again. So you could use the wait interval to set how often they can get points and prizes, and by the end of the campaign, none of that is going to be executed anymore. And one last thing is that once we're setting up the campaign, the admin is going to add funds to the campaign. So the campaign is holding the tokens that are going to distribute the prize. So if for some reason the prize amount or the total funds are depleted before the end of the campaign will end there. It will end prematurely because there are no more funds to be distributed. The transactions will still go through, but people won't be getting the prize anymore. And what the admin can do is that if he notices that the campaign funds are running too fast, he can go there at any time and replenish these funds so that he can make the campaign run a little bit further until the end. So this is just some arbitrary rules that we made to exemplify the optional approach. So the dog will trigger the transfer, and the transfer would be reviewed by the campaign. So let's say it sees, oh, the dog has 10 points, and as he's sending, let's say 10 tokens, he's going to get the multiplier 1-to-1, he gets 10 more points. The chicken is in the waiting interval, so the chicken is not going to get any more points. He has to wait for the interval in order to get points again. So once this is updated through the campaign just hands the transaction back to the wrapper, and the wrapper doesn't need to do anything fancy like in the past. You would have those approve and remove, but in this case, it's just the transfer. It just goes and triggers the transfer because there's no need to approve or revoke authorizations for the accounts, and the transfer will go through in success. So let's have a look at how this plays out in reality. Let's see the interactive demo. All right, I'm here on my website again, and I'm going to share the links in the description. So here is a very similar interface compared to the other demo that we did, but here we're using the campaign use case. So again, 4 steps just to configure, and we'll start playing around with the users. So I'll start by generating a new account for the admin, the one that controls the campaign. And here in this case, it is also the admin of the asset, but it doesn't need to be. You could be a wallet creating a campaign for USDC, even though you don't control USDC. You just want to provide an interface for your clients, your users, to participate in this campaign. So I'll generate a new account. Here I can see it's being generated with FriendBot. Again, all of these are running in testnet. And now I'm going to create the asset. So I'll create a name, let's say US dollar FIFO again. And let's say the code is USDF. Again, we can't change because in this use case we want to show an optional interface, therefore we cannot toggle this, but in essence this is going to be an optional interface. So I'm go ahead and create the asset. Now it's running the transactions to wrap the asset and prepare everything with the SAC. Once that is done, I'm going to add the campaign. So there you go. This is the moment I set the campaign attributes. So the campaign attributes are the following: price amount, the inflow and outflow multiplier, target points, wait interval, and the end date. So I'll start with the price amount. How many tokens do we want our users to get whenever they reach the point? So let's say they get 150 USDF. So 150. And what about the multipliers? So here you notice that as I input 1, it's actually showing 0.01. This is to demonstrate from the perspective of the developer how you need sometimes to think of these conversions depending on how you want to implement your use case. So we're using a big int, so we're just getting flat numbers. And the way we arbitrarily decided to do this is that each unit of the multiplier is 0.01 unit actually of a multiplier. So if we say we want to get a one-to-one relationship between points and the amount being transferred, we'll set it to 100. So we see 1 time the amount in points. If you want to set a different one, let's say 1.2 times, there you go, it's 120. So here I'll say that it is 0.5. So, it's 50, so 0.5. This means that whenever someone is receiving 100 tokens, they're going to get just 50 points, just half of it. And for the outflow, we'll do the opposite. Let's say the person will gain 1.2 times. So if I'm sending 100 tokens, I'll get 120 points. All right, so now how many points do we want to get? Let's set a target of 1,000 points. And whenever we reach 1,000 points, we are going to get the price of 120 tokens. Now let's set the wait interval. Whenever I reach the target and I get price, how long do I need to wait in order to start accumulating points again and participating again in the campaign? So let's say for testing purposes, that is a very short interval, but you can set anything you'd like. Here it's again in seconds, so you can add and see down below the conversion. So if we add this number, it will be equivalent to 11 months. We don't want that, we just want to test it. So let's say it's 5 minutes. So after 5 minutes, you can start accumulating points again. And the end date, let's say our whole campaign will stop in 30 minutes. So 1,800. Okay, so there's our configuration. Let's go ahead and click on configure. Now what it's doing it's deploying the contracts, the wrapper and the campaign contract, and it is configuring them with the initialize function. So it is setting those rules for those contracts. It is linking those contracts together. And then in the end, as a last transaction, it is going to go as an admin and add some funds. So here, arbitrarily, we are sending 10,000 tokens as funds for the campaign. So with the price of 120, this means that we roughly could send up to 9 prizes before it is depleted and can't send anymore. So we will need to refill the campaign. So let's wait a little bit. Oh, sorry, more, 90. Oh, my math's not working properly. So there we go, that's the interface, similar to the other use case. What do we have in here? We have the list of users on the top and you can generate new users. I'll go ahead and click here to generate a new user. We have the actions for the user here on the left, and on the right we have the whole tree of transactions. We can see the transactions coming through as the user is being generated, and you can see the whole timeline of the contracts being configured up until every transaction you run in the demo, so you can really see how they play out in a real use case. On the top, you have the details of the contract, so you can see the my dollar, which I misspelled in here. So you can see my classic asset, my SAC contract, you can see the interface wrapper and the campaign contract. And if you click here, you'll be taken to the Explorer where you can see the contract in the blockchain. So here I can see my campaign contract, I can see the entries that we have already, all of those attributes that I configured, I can see how they appear in the blockchain and how these transactions are executed. So everything that it runs, the data it's creating. So I really recommend that you play around, access these transactions and see how they play out, how they are going to be recorded in the ledger. It's a good exercise as a developer. So Getting back in here, let's play around with this. We have now an admin and we have an user. And by default, when we create a new user, we already sent 10,000 tokens to this user. So he has a balance of 10,000 and no points yet. If you look at the admin, he has infinite balance because he can just mint new tokens, and he has infinite points because he does not participate in the campaign. So it doesn't matter if he transfers or not, he's not going to get any points. We can see the campaign funds. So the whole campaign has 10,000 tokens that can be distributed, and you can see when the campaign ends. As an admin, you can send payments to refill some users, and you can also add funds to the campaign if you'd like. So for example, the campaign has 10,000. Let's say we want to already extend it further and add 5 more thousand. We just click here on send, and it's going to be done from the admin perspective. Once it's executed, there we go. We see here in the list, and we can click here to see in the Explorer. This is the transaction. And we can see here how it was played, how the information was recorded, the invocation, and everything that happened. We can see that since it came from the user, these units were minted and directly sent through a transfer to the contract, and they were added to the campaign funds. So if you look here, the campaign funds are now 15,000. All right, so let's go ahead, create another user, and start transacting in between them so that they can accumulate points. We have this target of 1,000 points. So I'm going to send a payment from this user. Let's see, do we have a third one? It's creating. I'm going to send some units, and I'll see how the multiplier will apply the points for both users. We have Jack and Sophia, and if we recap the rules again, we have two multipliers. Inflow is 0.5 and outflow is 1.2. This means that if I send 100 tokens, the one receiving is going to get 50 points, and the one sending is going to get 120 points. So let's make Sophia send some tokens to Jack. So Sophia is going to send Jack 500 tokens. As she's sending these dollars to Jack, she's going to get the outflow multiplier. So we would expect the 1.2 multiplier to apply to her and the 0.5 multiplier to apply to Jack. And there you go. She just got 600 tokens, 600 points, as Jack got 250. Now let's go ahead and send some more so that she can complete her threshold. So if we send Jack another 500, this should be enough to complete the 1,000 points. So her balance should go down by 500 and go to 9,000. But since she'll be completing her points, what we expect to see is that her points will go back to 0, and she'll get the prize of 120 tokens. So instead of going to 9,000, she'll go to 9,120, and she'll get the wait interval applied. So let's go ahead, click on it, let's wait for the transaction, and we should see the timer appearing here for how long she has to wait once it's completed. There we go, confirmed. Now she has to wait 5 minutes. Her points went back to 0. She got the balance with the prize, and now she has to wait. So she can still transfer and send Jack some more tokens, but this time she won't be accumulating points. So if she sends 100 tokens to Jack once again, Jack will receive the tokens, but Sophia won't be getting any points because she has to wait for the interval. There we go. We can see that Jack received the points, Sophia got no points, and Jack got 50 points as his multiplier for receiving. So that's it. That's how you play with this use case. I recommend you go ahead, create different users, play around with those timers, and see how these unfold through time. Now let's have a look at the code base. How was this implemented? Alright, here we are once again in the same code base with the examples, and we're going to show you what are the contracts that we use in this case, how we implemented those, and again, the playground. So just a quick recap. We have the contracts folder in which we have all of the contracts implementation in Rust, and we also have the playground where you can play around with the integration of these in JavaScript, and you can see how you can integrate those into your application. So everything here you see is within a workspace in the root directory of this cargo toml, and if you access both the root or the contracts folder, let me just navigate, now I'm in the root, you can run the Stellar CLI with contract build, and you'll be able to compile all of the existing contracts in this repository to WASM, so you have the WASM file and you can play yourself with these implementations. So it's running, there you go, they are all compiled. So for the campaign use case, what did we use? Instead of the enforced wrapper, we used the optional wrapper. So let me go there and have a look. We have these modules. It's a simpler implementation because we don't need as many rules as the enforced one. And again, we have a specific features trait which has the features that are only used in these implementation. They are not standard. So for example, we have the initialization of this wrapper with just the admin, the address, and the asset controller. And if you go down below, we have the implementation of the optional classic wrapper trait. So this is again coming from the standard traits package, which was added by the dependency we added to the cargo toml of the project with the path to it. It's here under the contracts directory, and you can have a look at it. It has the it has the standard interfaces for both the enforced and optional wrapper, as well as the asset controller and some common functionality that you can play around with it. So it's just to facilitate development and demonstrate how different builders can leverage the same standards and implementations to speed up and streamline their development process. So going back to the contract, we then import the optional interface and we implement it here for our wrapper interface contract. And the way we're doing that is that we're simply adding some get functions to get the status of the contract, if it is active, and we are exposing the transfer, which is the functionality that is going to be accessible by the users when they choose to use this interface. And what you notice now is that we are not managing the authorizations. This means that you can choose to use this wrapper, or you can choose to directly interact with the classic asset or the SAC. So here in the transfer, we just do something very simple. We check if the contract is initialized by checking the states that were already stored. We require the authorization for the sender to make sure that the person sending the funds has authorized the contract, and then we invoke the review transfer. And in a similar way as we did for the enforced use case, the review transfer uses from the standard traits an interface for asset controllers. So it doesn't know what asset controller is being used here. It doesn't know what this controller is going to apply in terms of logics or rules. It just cares that it has an interface that provides the review transfer method that is going to receive these parameters and that it should go through. So that's it. So that's a standardized way of implementing the wrapper without caring about which controlling rules are going to actually be used. So we run the review transfer, expect the campaign to do its magic, and once it's done, we just proceed to run the transfer normally. No adding authorization, removing authorization. We're just triggering the transferring and letting the base rules of the classic and the SAC decide if the transfer should go through or not. So the SAC and the classic will check if the user has balance, if the authorization is enough for the user to transfer. If there's anything that does not comply by the classic rules, then it won't go through. And it's not responsibility of the wrapper. The wrapper is just adding the extended capabilities and obeying to all the base rules of the asset. So this is way simpler than the other approach. And now let's have a look at the controller that we made here. So we have this campaign contract, which is very similar, but simpler than the one we did for the probation. So here again, we have a trait with specific functionalities that we're implementing here. So the way we initialize the rules of the campaign, a function to add funds and make sure that this contract has enough funds to cover the prices, and a get user function that returns the metadata about the user. If you look at the user data, it's basically an object that contains the points and how much the user needs to wait. So that's to provide the UI with the web application or the clients with necessary information to show feedback to the user, like the little timer that we showed in the interface and the filling bars about how many points you have and how much you need to wait. So if you go down here to the implementation of the trait, we are implementing the review transfer, which is the function that our wrapper is expecting to exist. And here we are just doing some small checks. We are making sure that the campaign is not over, because if it's over, we are going to issue an error. This is arbitrary. You could just have implemented it to move through and apply no rules. Here we just decided to issue an error to demonstrate that. Then we are going to require authorization from the wrapper, and that again is to ensure that no one is invoking the rules contract directly. So I don't want anyone faking transactions or reviewing transactions that aren't actually happening. So we make sure that only invocations that come through the wrapper are going to be authorized to move through. And then we process the user transfer. We process it for the sender and for the receiver. And here is where we're going to apply our logic. We are going to check if the user is eligible for a transfer. We are going to check if we have enough balance to pay the price. So if the user is eligible and if we have enough money to cover the price, then we're going to accumulate points according to the multipliers, and then we are going to pay out and so on. So we can see the way we convert points, the way we check if the user is eligible. I recommend you go through the repository and play with this code base so you get more acquainted on how these rules can be implemented. Now, if you want to see those in action, we can move to the playground over here. So let me just access the playground here. And just recapping, this is a node project with some scripts and a makefile to help you play around with these use cases. So we previously built the contracts and compiled those. So if we run make h or make help, we should see the whole list of commands we can use here. And we can use this deploy script to upload and deploy any of these contracts. So let's do it for the campaign one. Let me run it. And the way it's doing is it's running this TypeScript code to read the WASM file, creating an account temporarily just to deploy it to testnet. Then it's going to create a new instance and get the WASM hash and the contract ID. So you can use those in your own use case if you want to integrate to your own backend or web application. So here are those. And if you'd like, you can directly modify this makefile. I encourage you to do that. Get your own ID that you just deployed, and if you customize those contracts, go ahead, customize the rules, play with those, deploy it, and update the makefile with the ID. So once you do that, you'll be able to run the generate bindings, and you'll be able to see the TypeScript bindings for these projects, as we did in the other video. Now, if you want to see the use case in action, we have this test script for the campaign. And in the same way as we did with the probation use case, this has sort of a step-by-step use story of how to configure and how to deploy and how to initialize the users and play around with the campaign. So if we go ahead again to our makefile and use the test campaign end-to-end, we should be able to trigger those in testnet. So again, this is going to take a while because it's going to run a lot of transactions one after the other. But at the end, we should have this blueprint of how the whole use case played around. So I encourage you to go through this test file, check each one of the individual tests, how we are wrapping the asset, how we're uploading the contract, and every time we interact with these contracts here, we are using the classes we created here under the contracts folder. So in these classes, let me show you the campaign one. We have constants for the spec that we extracted from the bindings. We have the methods that our contract contains, and we have the class that wraps the functionality in an easy way for the clients to interact with, and the types for all the payloads, the payloads for requesting and getting responses from the contract. So this class is what is used in the tests and what I suggest you customize and play with. Let's wait a bit for the scripts to run. There we go. They just finished. So let me expand this so you can have a look. In the end, you can see the whole use case and how it unfolded. Again, we structured different phases, so you can see before the contract setup, how we were wrapping the SAC contract. And here you can see we're not adding custom control flags because this is an optional use case, so you wouldn't need that step. And here we are doing the whole setup, uploading the contracts, deploying new instances, initializing each one with the proper parameters. Then the admin comes in and funds the campaign by adding tokens. Once the contracts are initialized, during the setup of the users, so the users creating the trust lines, the admin minting units to the users, and then after everything is ready, the users transacting, accumulating points, and getting the prize. So if you want to test further, add further steps to these tests, I highly encourage you, play around, see how it's unfolded. And this was one example of the optional approach. Now, for the next video, I want to take a more hands-on approach and guide you through an exercise together to do a very simple approach for the optional one and show it from end to end on how to do it, deploy, and test. So, hope you have liked, and see you in the next video.